Hey, my name's Avery, and in this video we're going to be doing 3 multi-step derivative and integral problems. So in this first problem, we're trying to find the derivative of 3x to the 4th over e to the x, and this is pretty much a basic quotient rule problem, which says f prime times g minus f times g prime over g squared is going to give you your derivative. And so here our f is 3x to the 4th, f prime is 12x to the 3rd, g is e to the x, and g prime is also just e to the x. And when you combine those, so your f prime, 12x cubed, times e to the x, minus f, which is 3x to the 4th, also times e to the x over e to the x squared, that's going to give you your final answer here. I just put my negative 3x to the 4th term first so that the exponents are in order, but it's just going to be negative 3x to the 4th e to the x plus 12x cubed e to the x over e to the x squared. So our second problem, we're trying to find the integral of 4 raised to the 4x minus 6, and we have a formula for this as well. It says that the integral of a to the u times du equals a to the u times 1 over the natural log of a plus c. Here our a is equal to 4 and our u is the 4x minus 6, meaning our du is just 4. And since our du is 4, if we were to just plug into this formula, it's going to multiply everything by 4, which we don't want. So from here on out, we got to add a 1/4 into our equation. And so that's what I did here, put 1/4 and then plug in everything from this formula. So a to the u is 4 to the 4x minus 6 times 1 over the natural log of 4 plus c. And then you just combine your terms here. So it's going to be 4 to the 4x minus 6 over the natural log of 4 times this 4 from over here on the bottom. And this would technically be your answer. But if you want to simplify, basically all these 4s you can turn into 2 squared. And it'll help you play around with your exponents and get a little bit of a simpler answer. So the first one I did here was 2 squared, and with the squared, your 2 and your exponent, it's going to multiply with 4x minus 6 to give you 2 raised to the 8x minus 12. This is the bottom's staying the same for now. But then in our next step, I took this 4 on the outside, the 4 times natural log of 4, and made it a 2 squared. And same thing, since your 2 bases are now the same, you can subtract 2 from this negative 12 up here to give you 2 raised to the 8x minus 14 over the natural log of 4. And then one more time, this natural log of 4 can be natural log of 2 squared, meaning that your 2 and your exponent can move out in front of the natural log. And then same thing, as before, this 2 has an exponent of 1, meaning that it can be subtracted from this negative 14 to give you your final answer of 2 raised to the 8x minus 15 over natural log of 2. So in this final problem, we're trying to find the derivative of 5x raised to the 7x. And my first step here is to move that 5 to the outside so that we just have x as our base. And then we're going to do a change of base formula like Mr. Moore gave us. So 5 times the derivative of e raised to the natural log of x raised to the 7x. And you know that when exponents are raised to exponents, they multiply. So here, if you were to do a chain rule, you would have e to the u, where u would be natural log of x times 7x. And your du, once you work it out as a product rule, is going to be 7 plus 7 times the natural log of x. So I went back to this e to the u times d over du and plugged everything in. So you've got 5 times e to the natural log of x times 7x, and then your du was 7 plus 7 natural log of x. And then what I did here was change this x back into the exponent form. So you would have natural log of x raised to the 7x in your exponent formula, and that's so that we could get rid of that e, and it's going to turn back into 5 times x to the 7x, and then you've still got your du over here, 7 plus 7 times natural log of x, and then just go through and distribute this term to your du. So you're going to have 5 times 7x to the 7x plus 7x to the 7x times natural log of x. And then your final step is just to distribute that 5. So your final answer is 35x to the 7x plus 35x to the 7x times natural log of x.